Okay, we are at Unit 4 now. We're going to differentiate among the types of hose streams and nozzles. Okay, so these are factors that affect the stream, the hose stream. The velocity of water, the extinguishing agent, the flow rate of the water, extinguishing agent, gravity, right? Wind direction and velocity, air friction, operating pressure, nozzle design and adjustment, condition of the nozzle opening. So all these factors right here, that's a lot, right? So these are all the things to take into consideration when we're flowing water. Excuse me. So they will affect the hose stream, all these different things. We'll kind of explain how. So these are hose stream uses. Applying water or foam onto burning material to reduce temperature, right? That's what we're doing. We're reducing the temperature all the time. We're putting the water on the red stuff to make it cooler. You apply water or foam into open flames to reduce temperature so firefighters can advance hand lines. That's what we're doing. So the hose stream uses, what we're doing is reducing the temperature of the upper gas layer. So when we open that fog, we're cooling down that upper gas layer, right? We're dispersing the hot smoke and fire from a heated area. We can push it out, that's what we're doing with these fog nozzles, pushing out the windows. We're getting the gases from a heated area out. We're creating a water curtain to protect firefighters and property from heat, which again, you open that fog and you're creating like a curtain. It's just cool behind it because it's protecting everything behind it. It's spraying and protecting. You're creating a barrier between the fuel and a fire, so you're covering it up and protecting that thing. And you're performing hydraulic ventilation. All these things, we know hydraulic ventilation is when you open a window and take the nozzle, spray it. You're ventilating right with the water. Open the window, gets it right out. So here's the hose streams. It's the patterns they form, the nozzles that create the patterns, the types of control valves, and the factors that limit the hose stream. Okay. So here's the stream quantity and reach. So the size of the nozzle opening plus the nozzle pressure equals the quantity of water flowing from the nozzle. Does that make sense? Okay, the size of the opening and the pressure of pushing water through that opening equals the quantity of the water flowing from the nozzle, right? The amount of water, pretty simple. The size of the nozzle opening is the stream reach. Okay. So this is the hose stream shape. This right here is a smooth bore nozzle. It's a solid stream, right? You see that? It's pretty solid. It's a smooth bore, and it's a solid stream. This is the stream shape. You got your fog nozzle. You can do a fog stream or a straight stream. You know our fog that dispenses it in different areas. It's kind of broken up. It's a broken up pattern. Sprays it out, or you tighten it down and make it straight. That's your fog nozzle. The NFPA manufacturers categorize nozzles that produce variable hose stream patterns as adjustable pattern spray nozzles, right? We're going to call them fog nozzles. So it's basically what I just said. They break them up. Adjustable pattern spray nozzles, where you can adjust the pattern and it's a spray nozzle. All right, that's our fog nozzles. Okay, that's the fogs. Okay. If we just go back to our simple basics of the extinguishing properties of water, it can be applied in a variety of ways. You can do it all kinds of ways to get the water on. It's available almost everywhere. We named all the places. We can get it from the static sources. We can get them from hydrants. We have them in our tanks. We have them in swimming pools and everywhere. It's relatively inexpensive. It is. We tell people when you fill swimming pools, when they just water drain out, water's cheap. Water is cheap. It's very, very inexpensive. It's a great heat absorbing capacity it's the most common extinguishing agent. So yes, it's got a greater heating absorbing capacity, right? It's water absorbs heat. Absorbs a large amount of heat when it changes to steam, right? We know that. When it changes to steam, it absorbs a ton. 1700 is what it is, okay? So your heat, your water, this is water converted to steam. 1 to 1700 is that steam. Good nozzle control and coordination with tactical ventilation make for effective, efficient, and safe hose stream operation and fire control. That's a very good statement right there. Good nozzle control, okay? And the coordination we're talking about with tactical ventilation, so we're talking about communication, we're talking about pre-plans, we're talking about SOGs, SOPs, and your nozzle control. And if you've got a good plan and good people executing that plan, you're gonna have success. Why is water an effective extinguishing agent? It cools, right? It's readily available and it cools, that's what it is. The NFPA 1963 standard for hose connections identifies two general categories of hose stream nozzles, okay? Two. Straight tip nozzles and spray nozzles. For this, we're gonna be called smooth bore and fog nozzles. So straight tip is gonna be our smooth bore, right? Straight tip, smooth bore. And our spray nozzles are gonna be our fog nozzles. So when they say spray nozzles, it's our fog nozzles. Straight tip is our smooth bore. Okay, so hose stream nozzles. The smooth bore, fog, and broken. Okay, so they control the water flow, create reach, and shape the hose stream, right? That's our nozzles. That's what they do. They shape the hose stream, they control the water flow, and they create the reach, depending on what you're using. Here's our smooth bore nozzles right here. We've seen them. This is our bail, right? It's our bail. This is just our extended tips that we put on. And that's our smooth bore. So our smooth bore is our straight tip. Like they were saying, the water's gonna come out and get a good reach. It's smooth, it comes out straight. You're gonna get a really good reach with those. They operate at lower pressures. They're less prone to clogging with debris. Why would they be less prone to clogging with debris? Right, because it's an orifice about like that or that or that, you know, and things can go right through there. Whereas a fog nozzle is closed, right, and water hits it, it baffles, it sprays, it's broken up. So things can get caught in there, a lot of debris, sediment, rocks, whatever. These smooth bores, it's easier for water to get through. They can be used to have, you know, calves, compressed air foam. They may allow hose lines to kink due to less pressure, which we do know that. It's less pressure. It's not, I don't think it's that significant amount less, but it can absolutely, when you're flowing a smooth bore, they can, you know, have more of a tendency to kink. They don't allow for a selection of different stream patterns. What you see is what you get. You're flowing a smooth bore straight tip. That's what you're flowing, right? You got that. You can get reach and everything with it, but that's what it is. This is if you want to get more technical, this is the flow in gallons per minute from various size solid stream nozzles. So if you're looking at the nozzle pressure at 50, and here's the nozzle diameter, you know, it's 1.75 inches, and here's our nozzle pressure, you know. So that's if you want to get really technical. And again, here's our flow in liters per minute from the various sizes of solid stream nozzles. Again, very engineered, you know, depending on the nozzle diameter and millimeters is right here, and here's your pressure, pounds per square. Okay, so here's your fog nozzle patterns, straight stream, right? Very, very self-explanatory. Straight stream, it's gonna get straight. Here's your narrow angle fog, and here's your wide angle fog. So your wide angle fog is like we were talking about when you're protected, when you want to open out and protect and get behind it. That's your wide angle fogs. The fog nozzle characteristics, it is an adjustable discharge pattern, like we just said. So you can go in a fog nozzle from a straight stream to a wide angle, fog pattern. So it can provide protection to firefighters with a wide fog pattern, like we were just saying. That's what it does. You can go from a straight to a wide, and it gives you all that protection, just like that. It's used for a variety of applications, which is, it can be anything. Like we just said, it could be used for hydraulic ventilation, it could be used for protection, it could be used for just putting on room, it could be straight stream, you can knock things down. Very, very, very good. Variety of nozzle choices and manufacturing options. So we know this. We know that we've had different nozzles over the years. We know that every time we get nozzles, like different companies want us to try this and try that, and there's new technology and you got this and that. So there's so many different nozzles and manufacturers that you can get it from. It's just know your nozzle. Know what you have, train on it, become efficient with it, and become very, very aware of what you have. It can be used to apply certain types of foam. Certain types of foam can be blasted through it. Yep. Okay, so here is some illustrations of the fog nozzles. It's your basic fog nozzle, right? You've seen it with the pistol grip, fog nozzle. Here's a fog nozzle with pistol grip right here. This is the constant gallonage fog nozzle. Here's our constant pressure automatic fog nozzle. And here's our constant select gallonage fog nozzle. So you select the gallonage on there. And here you're gonna do the automatic. Abrupt changes in the reaction force of the hose line may throw firefighters off balance. Who's ever been in a fire or just training or doing whatever and you're not paying attention and that engineer either shuts the hose down or shuts the water down or charges the line with a lot of force or something happens in line, it'll almost knock you over. You have to pay attention. This is a very, I think people forget this a lot of times and they get cognizant, they're not cognizant of what happened, they get very complacent and they don't pay attention, but it will knock you right over if you're not prepared for it. Okay, so your automatic fog nozzle flow rates. So you got your high flow, your mid-range, and your low flow. Water flow adjustments in manual and automatic fog nozzles are required. Close coordination between the nozzle operator and the company officer and the pump operator. Okay, you have to know, you have to have a coordinated effort about what's going on in the scene, what you're flowing, how much. If that engineer doesn't know what nozzle you have or what you're flowing or what you're doing, he has no idea what pressure to give you. He'll know what's on there, but if somebody took a nozzle off and decided, well, I'm gonna put this on, before we start flowing, you have to have communication and coordination to do the right things on these fires. Fog nozzle pressure, we run at 100 psi. Is a designated operating pressure for most fog nozzles, 100 psi. Here you go, they go to 75, 50, 45 psi. There's less nozzle reaction, greater droplet size, like I said, those droplets that spray out from those fog nozzles, a lower density fog pattern, and less velocity, for sure, when you start going to 75, 50, 45s. Most operating pressures, like I said, are 100 psi. Broken stream delivery devices. These are things that we have that we need to utilize at times that can get into different places we can't get. So if you see right here, this is a piercing nozzle. So this nozzle is hooked to a hose right here, and this goes in and you knock it into this wall. So once you pierce it into a wall or wherever you're gonna go, you turn that hose on and it sprays like this. So it sprays everywhere. So it's got an end on it and it's a broken stream delivery device. So that broken stream is going everywhere. So once you get it out, you poke it through a wall and it's just wetting down everything. If you can't get into a certain place and you can get that through the wall, it's just wet everything. I mean, they're pretty cool devices. Same thing with a cellar nozzle. So a cellar nozzle is the same kind of like a piercing device, kind of, but like if you go into a cellar, it's a cellar. So if you're the above floor, you get a hole in the floor and you put this device into the floor, put it down. These right here are where the water comes out, and it will be like a wet willy, like when you're a kid that spins around, it's gonna fling water everywhere. It's gonna soak everything, it's gonna spin around, it's gonna flow, until you can clear things out and maybe get down there. It's a really good way to clear out somewhere that you can't get into before. You know, if you're having hard trouble getting downstairs or getting down to it, you can really do that. And the cellar pipe, the Rockwood cellar pipe, not really familiar with the Rockwood cellar pipe. We don't have those. I haven't seen those, but I'm sure it's the same concept. It's just your basic cellar nozzle. Nozzle maintenance. We're all bad at this. I know. I've seen it, and we're getting better. We are getting a lot better. So inspect after each use and at least annually. We do it annually for sure. I mean, and it's probably more like every month or so, every couple months. We'll do it. But if you're using that nozzle and you drag it through a fire, please check that nozzle, clean the nozzle, check it for debris, especially the like we just said, the fog nozzles. That you make sure everything's working appropriately, because it can be damaged. You don't even know it until the next time you try it full of water. Perform maintenance, care, and cleaning in accordance with manufacturer's recommendations. They all will have recommendations, and if you don't know them, get with your officers, get with your chiefs, get whoever has this information, you can get with them and they'll tell you exactly the manufacturer's recommendations on how to clean these things, how to take them apart if you need to, whatever needs to be done. Don't destroy them, don't adapt them and do things because it might validate or void the warranty. Only qualified technicians should perform technical maintenance. Like I said, don't go taking them apart, adding things to them and doing stuff like that. You can clean them and get the debris out, but anything else might void warranties. Inspecting nozzles. So you inspect a swivel gasket for damage or wear. You replace the worn or missing gaskets. I mean, that's simple. If it's leaking and you have gaskets leaking, you can replace gaskets. Look for external damage due to nozzle body, coupling and tip. The bail can be broke, the tip can be cracked or broke. Look for internal damage and debris. There's something, like I said, when people drag these hoses through the fire, sometimes they're not paying attention. You'll get all kinds of debris and gunk inside there, and mud from the front yard and stuff. So you do have to clean them off. Check for ease of operation of nozzle parts. Like I said, test the bail, spin the internal, like the swivel gaskets and all that stuff. Just check it. Ensure that the pistol grip, if you have them, is secured. So that's another thing. You yank a hose and a pistol grip bangs on a wall or two, and you can dislodge or loosen that pistol grip, and that guy gets it. He thinks he has it charged, and it comes back and hits him in the chest. Not a good situation. Ensure all parts are in place and in good condition. Right? That's simply what we're talking about. Nozzle care, thoroughly clean up, we just said that. Follow manufacturer's recommendations. Store the nozzle with the bail in the closed position, right? Store it in the closed position. Always store the nozzle closure. Don't drop them, don't drag them. Use flush setting on fog nozzles to remove internal debris. Shut off the water supply, remove the nozzle, and physically remove remaining debris. That means clean them. We've done it with a little brush sometimes, like when you get the mud and dirt and stuff. You take those little small brushes, like toothbrushes, a little bigger than toothbrushes, and you can clean out all the little parts on the fog nozzles. Okay, what are some differences between smoothbore nozzles and fog stream? We just said reach, what they do, the size, the capabilities, right? Your fog nozzle can straight to all the way wide. Your smoothbore is just straight. It's what you get, straight tip. How should nozzles be inspected and maintained? Yeah, they should be cleaned by us, fixed by the manufacturer or a technician. But yeah, we should be doing it after every use for sure. Nozzle control valves allow the nozzle pressure operator to start, stop, and increase or decrease the flow. This is your control valve. Open and close the nozzle slowly. Control increases the nozzle reaction. Right? Okay. So here's our ball valve. Like I said, this ball valve, this is very simple. So if you look in here, this is up and down. This is perpendicular. It's closed. Right? You open it, and that goes parallel and allows the water to go through. It's a very simple concept. This is your basic ball valve. It's a ball in there. This thing just goes whoop, whoop. Opens and closes. We know that. Opens, closes, and it just goes perpendicular and parallel. Here's your slide valve operation. Slide valve is about the same. It slides back. This piston goes up, closes the seal. Baffle goes down, closes it. That's the slide. Here's your rotary control valve operation. You turn the rotary on the valve, and it opens. You can see it. It opens the stem. There's the deflection stem. It opens and closes it. When you turn, you get your different patterns out of it by twisting the rotary. The hose string patterns, the size, the volume or quantity of water flowing per minute, size. The type is the pattern or shape of the water after it leaves the nozzle. Okay, that's what we just got done talking about. You got the volume and you got the shape. All right, so here's your stream flow rates. Here's just your master stream. Talk about this. You want to sit on that master stream and he's flowing it. Here's your hand line stream, and here's your low volume stream. Right? Again, here's a little bit more technical stuff. Here's your extinguishment time. This is just it's just a little bit more technical stuff. Okay, stream patterns. Like we said, here's your solid stream. Smooth bore, solid stream. Look at it. It's straight ahead. A lot of power behind it, but it's straight ahead. Here's your straight stream from your fog nozzle. It's tighter, right? Here's your fog stream when it's open. Like we said, that's your open fog stream. That's when it's wide. You're protecting firefighters. You're protecting stuff. That's your open right there. And here's your broken stream. What were our broken streams? Yeah, piercing nozzles. So it's like a piercing nozzle or a solid nozzle. So that thing protects, but you stick that in the wall and it'll just soak. It'll soak everything there, which is awesome. Here's your hose stream. Hose stream requirements. What do you need? Pretty simple, right? We need a truck with a pump. Yeah, we need water. We need a hose. We need our nozzle. That's our agent, our water. So you need your water, your nozzle, your hose, and your pump, your truck, pump truck. That's what you need. Solid streams. So they produce from a fixed orifice, smooth bore nozzle. They can reach areas other streams might not. That's what we're saying. It's a tighter, straight stream and smooth, and it'll get you some distance for sure. Like, because the fog's going like this out, and the smooth bore is just compact, straight. You're going to get a lot of distance, a lot of force behind it. Can penetrate and saturate burning materials. Trash fires and stuff like that, you can blast them and knock them down with that for sure. You can reach can be affected by gravity, friction, air, and wind, which we know gravity's going to pull it down. The friction, the air, the wind, it can all affect those streams for sure. But they do provide a large amount of water very, very quickly, these streams. When solid stream contacts wall or ceiling, the broken stream provides a greater surface area to absorb heat and cool the apartment. So you've got that solid stream, you bank it off the ceiling. I mean, it's just going to go everywhere. I mean, you're banking it, and it's going to cool so much by doing that. It really is. And it's a lot, like I said, it's a lot of water. It's a lot of water one time. Do not use solid streams on energized electrical equipment. And we know that when we go to code, we always want to make sure, is the electric company out, is power out, because sometimes you're flowing these things and guys aren't paying attention and they will flow that water into it. It's dangerous to be hitting those smooth bore lines right into the electrical equipment. You could get electrocuted at a minimum. Solid stream performance. Effective hose stream does not lose continuity until it reaches the breakover point and falls in showers of spray. They're easily blown away, right? Cohesive enough to maintain its original shape and required height. What's going to go? It's going to keep its shape, keep its height until it hits its target, right? Yeah. So the performance depends on velocity and orifice size. That's what I said. There's different sizes. You get the small ones up with large, and you can whatever size you need to do what you need to do. Here's a good illustration of it. 75% of stream volume. Yeah, 90% of stream volume right there. Yep. So you see that? So this is your velocity force. There's your wind blowing in. It's your breakover. So your breakover is right when you're flowing. Your breakover is when you're going up, and it starts coming down. That's your breakover point, and that's where your solid streams, your gravity starts taking over, and your wind. That breakover point is where this is the best right there. The fog streams. Fine sprays and droplets, like I said, it's all broken up. Got the fine spray everywhere. It exposes maximum water surface for heat absorption, right? The stream performance is characterized by the amount of heat stream absorbed, rate that water is converted to stream or vapor. So this is our fogs. We're spraying out, and it's a maximum water surface for heat absorption, right? You're getting everything. When you get in there, you're just getting everything. It can be adjusted to the situation. We just said the fog nozzles, you can go straight streams, you can go narrow fogs, you can go wide fogs, right? You can expose a maximum water surface for heat absorption, yep. Can be used for hydraulic ventilation, vapor dispersion, and crew protection. That's our wide fogs. Again, like I was saying, that hydraulic ventilation, when you get into it like a window or wherever you're going to put this thing, I mean, that fog nozzle is pushing water, but it is pushing everything out, and it will clear out that ventilation, what you need for sure. And protect your crew. If you need a barrier, that wide fog will protect you right behind you, and it's cool and everything in front of you and protecting firefighters and anything around it. It may be used to cool hot gas layers and hot surfaces. That's what we're doing. We're spraying those gases. We want to cool the gases. We want to cool the surfaces. So the difference, though, is we get what? A shorter reach or penetration than straight streams, don't we? When we got that wide fog. So with smooth bore and with straight streams, that fog, as soon as you start to fog it out, it's less, right? Your breakover point is done. I mean, it's going out and down. So you aren't getting as much penetration because it's all broken. It's not together. It's not one solid line. It's broken streams, right? Can be more affected by the wind than solid straight streams. Yeah, because it's all broken up droplets. So when you flow that, if you're outside trying to flow at a window outside or something, and it's windy, you could blow it and it won't even get to the structure. I mean, you'll blow everything out. Whereas a smooth bore straight stream, you get it on, it's going to hit. It's going straight until that breakover point we talked about. It may disturb the thermal layer if applied incorrectly, that we know that it can disturb it. It may intensify fire by pushing fresh air into the area if used incorrectly. Yes, it can. In different areas, if you're using it incorrectly, because it is a force of air coming behind this wall of water, that you could be pushing things down, and you could get it, if you're using it incorrectly, you could most definitely intensify the fire by pushing air down there with this fog of water. So the fog stream angle, you want a narrow angle pattern is highest forward velocity. It reach varies in proportion to the pressure applied. However much pressure you're running, that's what it's going to be. Your wide angle pattern is less forward velocity, right? Because it's wider, and it's got a shorter reach. I mean, that's just what we're talking about. That's your narrow angle and your wide angle. Narrow angle, wide angle, and you can kind of see just, you know, gravity is going to get involved in wind. Okay, so straight streams. Here's your straight stream, here's your solid stream right there. That's what they look like. And you can see how that would have a lot more force than your fog streams, right? Your fog streams are out. This is going to be more direct. Breakover point's going to be way back here somewhere, whereas your fog will be breaking down before it even gets there. You know, and the solid stream, the same. You know, it's a lot of reach. Broken streams. Here's your broken stream again, like we showed before. This is the piercing nozzle where those, but they break almost instantly. That's the thing, that inside of a structure you put that in, and it's gonna coat everything. It's gonna spray. Useless outside kind of, unless you can maybe use it for like a broken pattern. If you had to protect yourself from something, you can probably open it up and kind of spray like right in front of you. Hose stream limiting factors. We've talked about this. We've talked about gravity, right? That hose line go down. Your velocity loss, that's your strength. Your wind, which is going to blow, and your water droplet friction with air. That's your drag. So that's the wind beating against your atmosphere against your line. Okay, how are solid streams, fog streams, and straight streams different from each other? We just listed all kinds of ways, right? With the fog being, you know, easier in small areas inside, straight streams being good for distance and penetration. And what factors limit the reach of the hose streams? Again, just talked about it, right? The gravity, wind, you know, stuff like that. Absolutely. Okay, so explain how to operate the different types of hose lines, nozzles, and master stream devices. So this is the one firefighter method. See how we talked about before? We reached on this with this is this strap on his shoulder, holding that hose. This is for small ground cover fire, vehicle fires, stuff like that. Rekindling during overhaul, trash fires, fire in outbuildings are set. So smaller fires. A single firefighter can pull this line for the most part and take control and handle pretty much anything, right? That's pretty self-explanatory. So two firefighter method is minimum number for attack line during interior operations. Firefighters may apply a hose strap or hose tool to reduce the nozzle reaction. Nozzle firefighter holds the nozzle with one hand and the hose with the other, right? Nozzle, hose. Some people prefer the pistol grip. Some people don't prefer the pistol grip because it gets caught. You can have the hose and the nozzle, right? Correct? The hose line rests against the waist and hip. Same side of the hose, about 3 feet. We went back, like we said before. You want the firefighters on the same side of the hose. 3 feet behind the nozzle firefighters, backup firefighter, and that can be different. You know, that 3 feet is 3 feet is good. Some will want you to at least have some kind of contact every couple minutes to make sure you're still with each other. Communication. You hold the hose with both hands and rest it against the waist or leg. Let's keep the hose straight behind the nozzle operator. That's pretty straightforward. Do not direct a fog stream into a ventilated opening during offensive interior operations. If the interior crew is in a room or area immediately beyond the ventilation opening, do not direct a hose stream of any kind into the ventilation opening. We don't want to push that onto it, right? We do not. Okay. So this is the one firefighter method for large hose line operations. It's used for exposure protection, overhaul, master stream, if master stream is not available. Firefighter can use a hose strap or rope to reduce the fatigue, hold on. It doesn't permit much move. You can't move, like once you're in this position, you're pretty much in that position. Like when you have that large hose line, you're kind of there, right? You have to sit there, because it's hard to move, especially by yourself. Firefighters may need to anchor the hose line, so you got the two firefighters right there, you got him behind you, he's got the hose strap, he's got a hose strap as well. So they both got hose straps and they're both holding it. He's got his hands right, he's got his hands on there. You lean slightly forward to control the nozzle reaction.